12-volt high power doesn't exist anymore. Technically. It's transitioned to 12-volt 2x6, and NVIDIA has been using it for months, except they haven't been using it for months. 12-volt high power is also different from the 12-pin 30 series connector, but it's also different from 12-volt 2x6. You apparently need a 4-spring connector, or maybe a 3-dimple is fine, or maybe tulips or square plugs are best, or you can do whatever the fuck you want actually. Design oversights mixed with improper insertion cause an initial wave of problems. CableMod markets its solutions as superior on the back of this, says there's zero risk, and then later royally screwed its own design and issued a recall of all its angled adapters. A lot of people got the wrong idea that 12-volt 2x6 cables are intended to be used at 675 watts, but it's not. WCCF Tech reported that, quote, PCI SIG warns of potential overcurrent overpower risk with 12-volt high power connectors using non-ATX 3.0 PSU and Gen 5 adapter plugs, except PCI SIG mentioned neither non-ATX 3.0 PSUs nor Gen 5 adapters in that very post. And Corsair is mailing out plug lube. And so we're back to the title, which is 12-volt high power is a mess. It is both a spec and not a spec, depending on who you're talking to. It's like Schrodinger's 12-pin cable. As long as you never open the box, it both exists and doesn't. This whole thing started out as a cut and dry failure analysis of the CableMod angled adapters. We paid a third-party failure analysis lab to help us investigate CableMod's specific failures as a post-mortem because no official cause was ever released. But as we went further into this, that was around the whole recall a few months ago, we realized that what we really needed to do was start from the beginning, like the very beginning, like PCIe 6 and 8-pin cables getting created, levels of beginning. And so that's where we are. Now for this piece, we did something we've been doing more recently, which is we sent our final video to a number of peer reviewers and fact checkers to ensure accuracy of our research and statements. That's because this topic is complex and it spans several years of messy developments. Those reviewers included Aris of Cybenetics, the engineer who runs Cybenetics, a power supply validation lab that created the modern PSE rating system. Roman Hartoon, aka Der Bauer, who reviewed the video for accuracy of statements, particularly related to engineering and electrical topics, and also runs Thermal Grizzly. Elmor of Elmor Labs, who's the brilliant engineer behind some of the most useful testing tools in the industry, and a few anonymous engineers in the industry who were formerly involved in dealing with these specifications. Before that, this video is brought to you by the Antec C8 cases. We reviewed the Antec C8 ARGB a few months ago and found it to be an overall competitive performer using unique 160mm fans. There's also a version without included fans, and it's competitively priced while still offering attention to detail key elements like the airflow partition for better directing air intake. It also has high-quality kill management grommets and limited obstructions for bottom air intake. The ARGB variant includes all these features, but also two 160mm reverse blade fans and one 140mm fan. Learn more at the link in the description below. We've all been using 6 and 8-pin PCIe power connectors for GPUs for a very long time at this point. A couple of decades without any major controversy, at least anytime recently. And so we ran a survey that many of you participated in. Out of approximately 23,000 responses from our audience, 3.3% of users that had ever used the old PCIe connectors had a failure, and 4% that had ever used a 12-volt high power connector of some form had a failure. Now for purposes of this video, we may colloquially use the term PCIe connector. When we do that, we're referring to PCI Express 2x4 auxiliary power connectors, aka PCIe 6 and 8-pin. Although technically, all the connectors we are discussing today are PCIe. That's just to make it a little shorter. There's some sample bias there with all the attention on 12-volt high power, and even assuming some error in that number, that's a similar failure rate over a shorter time span. A lot of the 12-volt high power reports were of the CableMod adapters, which we already knew were problematic. And with that recent-ish CableMod adapter failure and recall, we're coming back to organize and conclude this story. First though, let's start with the CableMod adapter failures and look at what went so wrong that they felt the need to issue a government-level recall. Some of them are pretty gnarly and charred, so something must have been different in that design. A lot of this content today, too, is sort of a historical look back where we have compiled a massive timeline of events chronologically going through the whole saga. So this is going to be a lot of stepping through materials and documents today. We have some additional failed cards and connectors from CableMod, so credit to them for at least being involved in the investigation. But ultimately, we found 3 that were really representative or otherwise good samples, sent those in, did a cross-section on one of them, and we've got some pretty interesting stuff. So the 3 we're going to be talking about are, there's one 90-degree variant B, which we're calling number 1, and then there's one 90-degree variant A, we're calling number 2, and finally there is a 180-degree variant B, which we are calling number 3 in our imaging and photography. All 3 adapters melted around the GPU side 12-volt terminals, specifically the inner part inserted into the GPU. This implies that the area of high resistance was between the GPU pins and the male terminals, which matches the original partial insertion failures that we reproduced. On number 1, there are no obvious markings. On number 3's ground pins, there's a clear wear mark that indicates a gap of about 0.8 millimeters, which is small enough that it could have been created even with the retention clip in place. On number 2, we know that the connector was 100% fully seated because it melted off with the adapter. So this one should be a clearer indicator as to what CableMod specifically screwed up with its adapters. We have 2 other pairs of GPUs and adapters that we didn't send out from CableMod, and the angled adapters on those appear to have been seated at least enough to fasten the retention clips. So we have 5 melted CableMod adapters, and some, if not all of them, were installed correctly. The adapters commonly had inadequate solder fill, although number 2 had gotten specifically so hot that the solder reflowed away from the joints. CableMod and its factory used 100% tin solder. Manufacturing often requires using a lead-free solder, but it has the disadvantage of a significantly higher melting point, 232 degrees Celsius or so, versus tin and lead solder at 183 degrees Celsius, although it depends on a few other factors like the specific alloy composition, and there's a bit of a range. The extra thick copper layers on the PCB combined with excessive vias and big copper bars would have made it very difficult to heat the angled adapters enough to flow the tin solder and wet the mating surfaces. This may explain the excessive flux that the failure analysis lab we hired identified on number 1, which could cause electrical issues depending on the flux used and the amount, according to the lab. Bad solder fill and flux are problems, but as we concluded during the original 12-volt high-power investigation, the point of failure wasn't at a solder joint. The clearances between the solder pads for the sideband pins and 12-volt pins on CableMod's adapter are not adequate. The pads practically overlap here. You can see it pretty clearly. This, combined with manufacturing variants or tolerances, could lead to disaster and may have contributed to CableMod's recall. In the instance of our units, though, this isn't good design, but it also didn't lead to our specific failures. The lab also observed that the male connector lacks the proper H+ stamp that would signify 9.2 amps per pin rating as laid out by the spec. But so do the NVIDIA adapter dongles that shipped with our Asus 4090s. Having a letter and a plus sign obviously doesn't change the characteristics, but it may indicate process control or communication issues, and it could indicate a deeper issue. The failed adapters we sent in left too much space between the male connector and the PCB, allowing the connector to wiggle on its pins, which is the issue that CableMod tried to address with later 1.1 adapters by staking the connectors. Flexing pins could lead to fatigue and work hardening over time. In number 1, a sideband pin was visibly bent at the PCB. In fact, the CT scan of number 1 shows dramatic bending of most of the pins inside the connector housing. This is bad. This is also visible in the epoxied cross-section that the lab performed. Some of this may have happened when prying the melted connector out of the GPU, but the fact that it could happen at all is telling. Thermal Grizzly produces the WireView in collaboration with Elmor Labs. CEO Der Bauer ran a video on New Year's Day 2024 entitled 12-volt high power is just garbage and will remain a problem, where he stated that, quote,
"Nobody that is selling any kind of product that comes with any kind of 12-volt high power adapter can guarantee anything. That's just how it is. You are always left with a risk that something goes wrong as long as you use this connector."
We checked with Thermal Grizzly, and at the time of posting this video, the company has had 4 RMAs. Der Bauer noted that of those, 2 customers were unable to fully seat the connector due to backplate and water block obstructions. Now, there's also a new WireView Pro, which has some relevant changes to it. So this one will have detection of the sideband pins to determine if the 12-volt high power connectors are fully plugged in. It also has temperature sensing at the power connectors connectors, and it has hookups for external temperature sensors. Further, they've added an audible alarm that'll sound when an incorrect cable is installed, there's improper insertion, or when user-designated current or temperature limits are exceeded. The WireView completely skips soldering the sense pins and just jumps them internally. And on the male connector, the 12-volt and ground pins are soldered to two common bars that project out from the PCB. Pad spacing and solder fillet concerns are minimized because of this. Corsair sells a power bridge, as they call it, and we've seen no reported malfunctions. We ordered one, and the connectors on the one we got were more flush with the PCB than on the failed CableMod adapters. Our understanding is that CableMod outsold Corsair and Thermal Grizzly's angled adapters combined vastly, so although we can speculate, we can't draw firm conclusions based on a lack of failures for lower volume adapters. And this is a good time to remind everyone, including ourselves, to be consistent with the language, so this is just for me to remember as much as it is for the audience. Cables and PCB adapters are different. So PCB adapters predictably use a PCB, printed circuit board, and in the specification, there is no official guidance for a PCB angled adapter. It is not a thing that they present guidelines for. Now, none of these points we've discussed are cables other than the prior partial insertion failures that we've reproduced. Those are cables. As for the CableMod adapters, the failure analysis lab stopped at observations, leaving some of the speculation to us. We believe the lack of solder fill and the space between the PCB and the connector may have encouraged the terminals to flex in their housing, worsened by the leverage that's placed on angled adapters by taut cables. In combination with this, anchoring the terminals to the PCB prevented them from twisting to conform to the pins on the GPU side. We don't entirely agree with Igor's November reassessment, but we do agree on that last point. The spec for 12-volt 2x6 cables requires 25 millimeters of free wire behind the male connector without anything, quote, that repositions them from their natural relaxed state or location where they enter the housing. And, quote, wires are to be dressed in such a manner to allow the terminals to float freely in the pocket. From what we've seen in the specs, this specific side of the connector, shown on the screen now, is designed to be installed on a cable and is not shown mounted on a PCB in the specs. It seems possible to circumvent the problem by building it something like the Thermal Grizzly adapter, or perhaps by seating the connector flush with the PCB, like on the Corsair adapter that we bought on Amazon. We definitely wouldn't guarantee that anything involving 12-volt high power is risk-free, though. We're with Der Bauer on that for sure. This is something that CableMod should have been more careful with in its marketing. The design oversights make that impossible. To be clear, though, we also wouldn't guarantee that 6 and 8 pin is risk-free. Statistically, its risk factor appears to be at least slightly lower, at least partially due to more overhead in the spec. So let's get into that. A major reason that connectors melt is because something causes high resistance and then dumps the energy as heat. And in the case of the original 12-volt high power connectors, working with the failure analysis lab highlighted two factors. One was partial connection in combination with cable tension, and the other was foreign object debris. Failures with poor connection were repeatable in a lab setting and were a widespread root cause for the first wave of melting. This was hinted at as early as August 2022, when NVIDIA made that PCIe SIG presentation about 12-volt high power cables melting when pulled at sharp angles. Loss as heat in a circuit can be calculated with the equation P equals I squared R, where P is the power lost, I is current, and R is resistance. Heat loss increases with both current and resistance. Current should theoretically have a flat limit across all pins. But as the CEM says, quote, due to variations in contact resistance, an individual pin may see more than 9.2 amps of current depending on cable contact resistance non-uniformity. Larger normal forces, or a tighter squeeze, and metal-on-metal wipe areas mean lower electrical resistance and lower heat, but it also makes it physically harder to seat the plug. There are a few disadvantages to 12-volt high power versus PCIe 8-pin. PCIe 6 and 8-pin power connectors are comparatively big, and they slide into place easily and with a noticeable click. As several have pointed out, the 150-watt spec for 8-pin PCIe connectors is usually well below the rated maximum capacity, whereas 600 watts is closer to the rated capacity of 12-volt high power connectors, reducing the margin for safety. Providing 600 watts requires 4 big 8-pin connectors with 12 12-volt wires, providing redundancy and spreading out heat, or a single 12-volt high-power connector densely packed with only 6 12-volt wires. If one 12-volt high-power pin heats up, it may soften the plastic and lead to a cascading failure, especially on the cable side, where the plastic is actually what holds the metal pieces in place. Checking with Der Bauer on this concept of softening plastic housing and cascading failures, Roman chimed in as well. He noted this, quote, "If there's significant contact resistance on the connector side, this could increase drastically to maybe 10 to 20 watts. And 10 to 20 watts on such a small part will heat up over time, which can then cause the connector to melt or at least become soft in regards to the plastic. If the plastic becomes a little softer, an already slightly bent pin can bend even more, again increasing the contact resistance and leading to the failure," end quote, aligning mostly with what we were just saying as well. Also, because of the tighter safety margin, factors like alloys, tolerances, structures, the actual material of the plastics, and contact areas all require more standardization and more diligence from every random manufacturer that wants to make one of these. And a quick note here about the 30C threshold that appears in the specs. Seeing a connector rise 30C above the metal and air literally around the connector, not the room ambient, is an indication that the connector can't keep up with the heat dissipation and could indicate the beginning of thermal runaway. It doesn't have to do with the safe temperature of the connector or the rated power delivery at a given temperature. It also doesn't have to do with the greater room temperature, as those who worked on the spec told us. This was something we asked them because it was unclear to us at the time. It is, however, about the immediate ambient of the connector and what surrounds it directly. The older connectors can and do fail. As examples, we found the two most recent viewer emails we'd gotten about melted 8-pin PCIe cables and connectors and bought both power supplies and their associated cables. Both viewers had used stock daisy chain PCIe connectors included with their power supplies to power 300 watt plus GPUs. Silverstone's warranty sheds some light on the issue. The company doesn't cover what it calls connector overuse, which it defines as, quote, damages or malfunction resulting from the use of a graphics card or expansion card with a single PCIe 8-pin connector that exceeds standard 225 watt total power draw, 150 watts from PCIe 8-pin, and 75 watts from PCIe motherboard slot. Similarly, a graphics card or expansion card with dual PCIe 8-pin connectors that exceed 375 watts total power draw, or 300 watts from two PCIe 8 pins and 75 from the motherboard slot, will also not be covered under warranty. Basically, using Silverstone's daisy chain connectors almost always avoids the warranty, officially anyway. And if you ever have a failed component, you can email tips, T-I-P-S, at gamersnexus.net. Let us know what the failure is. If it's in the warranty window, even better, because then we can buy it from you and we can use it to test the manufacturer's warranty. This chapter covers why 12-volt high power even exists to begin with. So, PCIe 8-pin connectors and cables are generally overbuilt, but not always, and not to a consistent standard. However, because there's more room in the spec, it's more likely that they do end up overbuilt, even if accidentally. Now, it's known that running more than 150 watts through an 8-pin PCIe connector can cause melting in edge cases, as shown in Silverstone's nicely illustrated warranty page, actually. GPU power consumption requirements have increased, though, and they're not really showing any signs of slowing down. So the seeming starting point for all of this is that in order to reliably get more than 450 watts of auxiliary power into a smaller package, there was going to have to be a new cable. So that seems like the starting point for at least NVIDIA with their stuff. And the new solution ended up being 12-volt high power. The 12-volt high power connector is smaller, and one of the reasons NVIDIA wanted to do this is because it makes it easier to cool the card. Another challenge of theirs, because more power, more heat, especially if the general area it's in is not really expanding. So 12-volt high power theoretically enabled better cooling on the card by reducing the PCB length. And in practice, this actually was true. If you ignore everything about the cable itself and you look at just its area and the ability to chop the PCB a little sooner because it's fewer connectors, it takes a smaller footprint, then ignoring all other factors, it is in fact true that pushing air through a flow-through design will generally improve versus into a PCB wall. So we've seen, for example, at a fixed heat load around 5 degrees Celsius, reduction in GPU temperature by pushing through versus getting obstructed. Other reasons they might have wanted to do this would be to allow for more flexibility in PCB design, reducing cable clutter, I guess, things like that. A full-size PCIe by 16 devices can draw 75 watts through the PCIe slot. Not all of that is 12 volt. Modern GPUs require more than that, of course. That's why there's cables on them. And for years, that additional power has been delivered by 6 or 8-pin connectors. Both styles of connector carry the same 3 12-volt power lines, but 6-pin connectors are rated for 75 watts, while the extra 2 pins indicate a higher standard that can carry up to 150 watts. On September 17th, 2020, the NVIDIA RTX 3000 Founders Edition cards launched with a new 12-pin connector. It was a big change in form factor, but electrically, nothing new. 6 12-volt lines and 6 grounds numerically matched dual PCIe 8-pin connectors, which you can find in some other cards. Some dedicated power cables for these cards were released, but for the most part, everyone used the included adapter dongles. We're now aware that NVIDIA had been considering PCIe power replacements for years before this, some of them more exotic. But the 12-pin design was an off-the-shelf part from Molex, like the old 8-pin connector, and behind the scenes, both 30 and 40 series went through multiple connector revisions before shipping, but we're getting ahead of ourselves. The Peripheral Component Interconnect Special Interest Group, or PCI SIG, and its PCI Express Card Electromechanical Specification, or PCIe CEM, Revision 5.0, version 1.0, was released on June 9th, 2021. This was the first time that the 16-pin 12-volt high-power connector was officially defined, but there were no GPUs with 12-volt high-power connectors as defined here. So uncynically, for a moment, 12-volt high-power as a connector was smaller. They achieved that. It therefore obstructed the airflow less. It reduced cable clutter. It did allow for more flexibility in PCB design and shorter PCBs. Cynically, however, pushing for a new connector allowed NVIDIA to do one of the things that NVIDIA does very well, which is get in front of the industry and pull everybody behind it, including its competitors. And that is just like what we saw with RTX, DLSS, and to some extent now, AI. The early 12-pin connector was a soft launch that predated the spec, and it lacked the 4 sideband connections that would be added to make 12-volt high power. According to John Garreau, NVIDIA and Dell Corporation were listed as co-sponsors of the sideband edition. PCI SIG is a consortium. NVIDIA is a member, as are Dell, Intel, AMD, and dozens of others. To paraphrase an insider we spoke with, there was no reason to think that adding 4 signal pins to a tried and true design would cause any problems. The 4 sideband pins were Sense 0, Sense 1, Card Power Stable, and Card Cable Pres number. At this point, the PCIe CEM said that, quote, the add-in card, high-power auxiliary cable, and power supply may optionally implement all, any, or none of these 3 features, end quote. Card Power Stable and Card Cable Pres were data signals that were intended for enterprise. Sense 1 was unused, and Sense 0 signaled whether 450 watts or 600 watts was available. Grounding Sense 0 meant 600 watts. Opening Sense 0 meant 450 watts. Now here's one of the sort of troubling things that you might not have known. There's really no validation, certification type of process for this stuff. A manufacturer could feasibly do whatever they want without ensuring that the cable can actually meet these various loads. So PCI SIG, even though it sets a specification, they don't step in and validate and stamp cables. It's not part of the scope of what PCI SIG does. It's up to the manufacturers to police themselves, and we know how well that goes. They could also do whatever they wanted with PCIe 6 and 8-pin. It's just that there's more overhead there, and the cable has been refined over decades now. The ATX version 3.0 Multi-Rail Desktop Platform Power Supply Design Guide, revision 2.0, was finalized on February 1st, 2022. Revision 2.0 was the first release of ATX 3.0, and as of today, it's up to ATX version 3.1, revision 2.1a. As you may have guessed based on that mess of a name, Intel curates the ATX spec. They've always been great at deciding naming, but it's really a collaborative set of guidelines to keep hardware compatible. Intel does some voluntary validation, and third parties like Cybenetics do a lot more, but the spec wasn't and isn't law. The first release focused heavily on power excursions, which were a huge concern at the time from the RTX 30 series and its massive transients that we covered back then. But it also included the as of yet unused 12-volt high-power connector, which was marked as, quote, required for power supplies greater than 450 watts. The 12-volt high power section referred readers to PCI SIG for details. Most importantly, this release included updates to the 2 sense pins. According to the ATX 3.0 spec, power supplies with native 12-volt high power were required to support both sense pins and use them to signal whether the PSU itself could deliver a given wattage. The 4 possible open ground combinations of the 2 pins were used to signal 4 sustained power tiers, not 2. So it's 150 watts, 300 watts, 450 watts, and 600 watts. Leaving both pins open signaled the lowest power capability of 150 watts. And, quote, if the add-in card does not monitor these signals, it must default to the lowest value in this table, 150 watts, end quote. This conflicted with the PCIe CEM. The sense pins were required on the power supply side, and the GPU was required to monitor them. In March 2022, the ATX 12VO 2.0 specification came out. It was released only a couple weeks after the ATX 3.0 spec, but it already included a mechanical change to the connector to protect the sideband wires. This change wouldn't be reflected in the PCIe CEM for months, and it would take even longer for manufacturers to catch up. Immediately afterwards, March 29th, 2022 or so, the RTX 3090 Ti launched, and this was the first card that used a 16-pin 12-volt high-power connector, but the adapter cables that shipped with these cards were the existing 12-pin style. So, connectors were keyed in such a way that 12-volt high-power plugs could fit into any 30 series card that obviously had a receiving end, but 12-pin plugs couldn't fit into any 12-volt high-power sockets except for the 3090 Ti's. You see where the confusion starts early with this. Like we said, it was a mess from the start. And the 3090 Ti was functionally a test platform for the upcoming 40 series. The 3090 Ti didn't comply with the Intel spec from February of that year, just before it, which stated that leaving both sense pins open should actually signal 150 watts, not 450 watts. On August 25th, 2022, it began. PCI SIG showed a grim internal presentation from NVIDIA about CEM5 16-pin 12-volt high power, as they called it. Quote, failures have been observed in testing in certain cable routing conditions from power supplies and test boards that generate side load on the interface. This was a, quote, call to action for the WG to ensure the CEM specification is sufficient to prevent failures in the field. Time to failure observed from 10 to 30 hours. All samples made with copper alloy terminals and 14 to 16 gauge wire. Samples tested were both discrete wire and internally bussed with solder terminations. 3 different manufacturers have been tested. At least 10 sample assemblies have been observed to either melt or generate hotspots, end quote. The cables shown in this presentation were real 16-pin 12-volt high-power cables, which were still rare in the wild as no GPUs required them. NVIDIA tested non-adapter cables, it tested 14-gauge cables, it tested both discrete wires and a soldered bus, and it tested multiple manufacturers. The implied conclusion was that none of it mattered. These tests were mostly concerned with bending and side loading under high load. This was the source of the bend radius recommendations still seen today, and you should still follow them. On September 10th, WCCF Tech leaked an email that had been sent to PCI SIG members in the wake of that presentation, which stated that, quote, PCI SIG has become aware that some implementations of the 12-volt high power connectors and assemblies have demonstrated thermal variance, which could result in safety issues under certain conditions, and, quote, we recommend members work closely with their connector vendors and exercise due diligence in using high power connections, particularly where safety concerns may exist, end quote. WCCF Tech ran this under this headline, quote, PCI SIG warns of potential overcurrent, overpower risk with 12-volt high-power connectors using non-ATX 3.0 PSU and Gen 5 adapter plugs, end quote. Neither non-ATX 3.0 PSUs nor Gen 5 adapter plugs were mentioned by PCI SIG in that memo. That was inserted by WCCF Tech. So we're not sure why they said that, but the net result of it was that for months after this report, the conversation shifted to revolve around adapter cables specifically. And for NVIDIA, this was nightmarish timing with the 40 series on the horizon. As more outlets reported on the story, NVIDIA emailed Jay's 2 cents to say that, quote, I think you're worrying about issues that don't exist. We have thoroughly tested our power adapters and expect no issues. Potential customers who are concerned can use the RTX 40 series connector solution with confidence, end quote. On October 12, 2022, the RTX 4090 launched. This was the first time a true 16-pin 12-volt high-power connector was required, but all cards shipped with adapter dongles. NVIDIA's adapters were able to intelligently ground or open sense pins based on how many 8-pin cables were connected. This meant that, as we saw in our review, connecting just 3 of the 4 cables would reduce the overpower provisioning permitted through overclocking software at the time. The 4090 launched alone for the first month though, so at first, all of the 12-volt high power problems occurred with 4090s, because that's all there was. Less than 2 weeks later, October 24th, the first report of a burned out adapter hit Reddit. By the 25th, there were 2, and NVIDIA confirmed to The Verge in a statement that it was, quote, investigating the reports. Starting on the 27th, Igor's lab took the wheel and posted a rapid-fire series of articles. The articles started with the headline, quote, "The horror has a face. NVIDIA's hot 12-volt high-power adapter for the GeForce RTX 4090 with a built-in breaking point," end quote. At this point, Igor operated under the assumption that, quote, "it's the adapter solution exclusively provided by NVIDIA to all board partners, which has fire-dangerous flaws in its inner construction. And, quote, the native 12-volt high-power cables of the better power supplies show that it can be done differently," end quote. He speculated that the solder bus within the adapters was fragile and inadequate, and that if any connections were to break, quote, "the inner bridge between the pins is too thin, resulting cross-section, to compensate the current flow on 2 or 3 instead of 4 connected 12-volt lines," end quote. He assigned blame to Astron, a vendor for the connectors, and claimed that crimping rather than soldering would fix the issue. On the 30th, we published the start of our first-party investigation of the issue. We tested adapters with many combinations of broken solder, cut cables, and overclocked GPUs, but didn't come close to melting anything. Our conclusion was that although failures were clearly happening, it wasn't due to inadequacy of the bus bar on at least our units, and we requested melted cables from viewers to further the investigation. Speculation about solder joints and bus bars slowed down at this point and redirected towards the contact design of the adapters. The design used in NVIDIA's Astron manufactured adapters would be termed 3-dimple versus the supposedly superior 4-spring design from NTK and subcontractor 3Con. Theories about these were being created and discarded almost literally hour by hour at times, so we went dark while we gathered information. On November 11th, a complaint was filed with the goal of starting a class action lawsuit against NVIDIA, filed in the Northern District of California by New York resident Lucas Genova, largely leveraging New York laws. Genova vs. NVIDIA Corporation stated that, quote, "the melting has affected both the 12-volt high-power adapter and the native 12-volt high-power cable," end quote. It claimed that 23 reports of melting had been posted on /r/NVIDIA on Reddit by the 7th, just 2 weeks after the first report. By November 14th, multiple outlets had misreported a mechanical change as new that had actually been in the public ATX 12VO spec since March. NVIDIA separately confirmed a real change to Igor, though. The sideband connections would be shortened so that, quote, "the sense pins only become contactable when the plug has been fully inserted," end quote. That's called foreshadowing. On November 16th, we melted a connector. Actually, we got pretty good at melting them. It's currently at 258 degrees.
I think we see the smoke, Steve.
You see the smoke? Andrew, can you see it okay? Did you get the shot? This is the best connector in the world! Look at it! And if you've never seen that video, it's worth a watch, at least for our reactions to it. To start, we worked with BuildZoid directly to test and eliminate some of the popular theories. We manually spread the split terminals in an Astron adapter as far apart as possible, but saw no significant change. We cut 4 12-volt terminals off of an adapter and ran a 600-watt load through the 2 remaining pins, but still saw no significant change. We then sent several viewers' failed adapters to a failure analysis lab, which found debris molded into the housing, called foreign object debris, metal burrs on the terminals, and scraped off plating. These were all problems, and similar problems may have led to some adapters melting, but they didn't melt ours. Most of the failures known to us up to this point happened with partially inserted connectors, which is what we were able to replicate twice in one night. As we were then, we're aware that this doesn't account for every type of failure, and we want to be as clear as possible here, because we used the phrase user error a lot. And to quote ourselves, even if it is user error, at some point, it's like if the design is so bad that it encourages user error with any amount of regularity, then it is a combination of user error plus design error. Improper insertion may be softer phrasing for the same concept here. So our conclusion was that it was a mix of bad design, of a new standard, and of improper insertion as a result of both of these two things. Now, the lack of additional power headroom means lower tolerances, plus the stricter requirement for quality metals and the stricter requirement for quality high heat plastics means that corner-cutting manufacturers wouldn't be able to cut the same corners with the same success as they could on PCIe 6 and 8 pin. The tight 12-volt high-power connector with its 4 additional sideband connections and no tactile click hidden deep inside the shroud of a gigantic 4090 could easily be left partially unplugged. We found specifically that not fully seating the connector and then pulling it to the side would reliably melt it. And we also clearly identified markings on some adapters that indicated they were melted while partially inserted. To quote ourselves again here, but most likely it starts out acceptable but incorrect and accidentally gets tugged to being meltable. And this isn't a get out of jail free card for manufacturers to block or deny RMAs. In fact, there was a leak that NVIDIA had allegedly told manufacturers to just approve all of those related RMAs. Immediately following our video, NVIDIA posted a statement that, quote, "We are aware of about 50 cases globally, and, quote, our findings to date suggest that a common issue is that connectors are not fully plugged into the graphics card," end quote. Based on this, there was a 0.04% to 0.05% failure rate related to the approximately, at that time, 125,000 RTX 4090s that had been sold in about the first month. Also, NVIDIA stated that, quote, "We are investigating additional ways to ensure that the connector is secure before powering on the graphics card." As NVIDIA stated in an internal document afterwards, quote, "Testing of impedance versus gap spacing between the receptacle and the adapter showed that an increase in gap spacing corresponds to an increase in impedance, and, quote, the impedance increases significantly after 1.5 millimeters of gap spacing, and some pins violate the 6 milliohm PCIe CEM5 electrical spec," end quote there. After this, things slowed down. In December, PCI SIG sent an email to members saying that, quote, "When implementing a PCI SIG specification, members are responsible for the design, manufacturing, and testing, including safety testing, of their products. But it's unclear to us whether that was directed from or at NVIDIA." In February, months after we melted a 4-spring connector, ATX 3.0 revision 2.01 stated that, quote, "Crimp contacts inside of the cable plug are recommended to use the 4-spring design instead of 3-dimple design, which will increase the contact area for electrical current flow inside the 12-volt high-power connector and reduce the temperature rise of each contact," end quote. This statement was later altered, and today it reads this, quote, "Crimp contacts inside of the cable plug can," it's their typo, "either use the 4-spring design, 3-dimple design, or equivalent design," end quote. Without any explanation we could find, they removed the text about increasing the contact area for electrical flow and for temperature reduction, so that's just gone. In March, Genova v. NVIDIA was voluntarily dismissed with prejudice by Genova, meaning it can't be brought back to court. A reason was never officially disclosed. It could be a lot of things. One possibility is due to a personal settlement, but there is no evidence of this at this time. We don't know why it was dismissed. And that brings us to part 6, the melting, CableMod edition. During all the fuss about adapters, toasted GPUs, and bend radii, CableMod was consulting with Igor from Igor's lab to develop a rigid 90-degree and 180-degree set of adapters, with the final form revealed by Igor in March of 2023 and on sale by the end of the month. These were small PCB-based extensions, not really adapters, designed to enable a sharp bend away from the GPU. This was pitched as a safety feature, not just a cosmetic one, since it had been known for nearly a year that 12-volt high-power cables could not be safely bent or pulled at sharp angles. CableMod wrote, quote, "No wire bending ensures full contact with all cable terminals and zero risk of thermal issues through excessive wire and terminal stress from tight bending radii," end quote. These adapters incorporated what were supposed to be several improvements based on the ongoing controversy. They used 4-spring NTK contacts, as recommended by the ATX spec at that time, although again the spec would later change. They had a specified copper thickness of 70 microns within the PCB, reportedly double the usual. They had 3 massive copper bars soldered to the PCB as reinforcement for pairs of 12-volt traces. They had an aluminum housing mated to the PCB with a thermal pad for heat sinking. They used PCB rather than plastic as a cover plate for additional heat resistance. And they used the shorter sense pins that NVIDIA had been considering in the female connector. Except that doesn't appear to have been true. As far as we can tell with our units, the 4-spring terminals and the shorter sense pins didn't make it into production for these CableMod adapters. Igor showed detailed close-up shots of the terminal pins in a prototype adapter, which clearly don't match the ones in our failed 1.0 adapters. The sense pins on the female connectors weren't any different from contemporary pre-revision connectors on GPUs. Finally, the claimed, quote, 3 additional copper bridges that reinforce the 3 12-volt strands on the board, 3x2 pins, where, quote, 2 pins are electrically combined in each case for safety reasons in case one of the 6 12-volt strings should fail externally, end quote, are not actually connected like that, at least not in ours. In our CableMod 90-degree adapters, the 2 outer bridges are connected to all 6 ground pins, and the inner is connected to all 6 12-volt pins. So while at one point it may have been that way, it wasn't in our production units. The 180-degree adapters are the same, but with twice as many bridges. We don't believe these factors were directly to blame for the failures, but it wasn't a good sign that the 1.0 retail adapters didn't match the exclusive first review of them by someone who was so close to their design and seemingly, at least in some way, consulting on it. 2 months later, on May 18th, Northridge Fix posted a video called 4090 FE connector melted with CableMod adapter installed, 40 series cards should be recalled. It was later established that part of this initial batch were 8 damaged units sent by CableMod as part of its RMA process, sent to Northridge Fix for being repaired. The shop has continued to receive damaged cards to date. CableMod claimed that at this point it had 8 reported failures out of more than 50,000 adapters sold, a 0.016% failure rate if that's true, and that 4 of those were confirmed to be due to partial insertion. We now know that 50,000 number possibly included all 12-volt high-power products sold by CableMod at that time, not just adapters. So the true failure rate of the adapters would have been higher. This was within 2 months of the product launch, and on adapters that were specifically designed to resist this exact issue, so that's pretty bad. Worse still, at least one of the adapters had definitely melted into place while fully seated, indicating a new problem. And that problem would lead to CableMod's recall of its faulty adapters. In July 2023, Hardware Busters revealed that the 12-volt high-power connector would be replaced with the compatible but revised 12-volt 2x6 connector in the upcoming PCIe CEM 5.1. Igor then discovered that newer NVIDIA cards had silently rolled out an early variant of this connector as early as April of 2023. By August, CableMod was working on the CableMod Early Adopter Program to replace the original 1.0 adapters with an updated 1.1 version. It stressed that, quote, the issue seen with our V1 adapters can't be pinned on NVIDIA and the new 12-volt high-power standard directly, end quote, accepting the blame and the responsibility for what was at that point a growing but, quote, at most 0.1% failure rate, according to the company. The new 1.1 adapters incorporated these changes. First, they used the 12-volt 2x6 connector. Secondly, the connector was made to fit more tightly following suggestions from Jay's 2 cents. Third, the connectors were staked to the PCB to prevent wiggling. And then CableMod remained confident in its other non-PCB-based 12-volt high-power products. like the cables, for example. Finally, on August 7th, 2023, the current PCIe CEM revision 5.1 version 1.0 rolled out, incorporating a full year's worth of ECNs, or engineering change notices, that mostly revolve around the new 12-volt 2x6 connector, with the original 12-volt high power definition bumped down to an appendix. Both sense pins are marked as required, and add-in card partners are required to monitor both in order to draw any power. The open condition has changed from 150 watts to 0 watts, with 150 watts now signaled by shorting the two pins together. AICs, but not PSUs, are required to support the primary function of the previously optional card cable pres signal to provide, quote, a signal from the add-in card to the power supply that the add-in card has detected the auxiliary power connector is correctly attached, end quote. Power and ground pins are extended by 0.25 millimeters, and sideband pins are shortened by 1.25 millimeters. There are other numbers online cited for these mechanical changes, but these are the correct ones that are defined officially by the specification. Exact terminal length isn't part of the CEM. They say, quote, plug power and ground pins must be fully engaged prior to sense pins making contact in a worst case tolerance condition, end quote. But we've seen NVIDIA documents showing that the terminals are lengthened by 0.6 millimeters in its own adapters. Several tolerances are also tighter. All of these changes are intended to keep cards from drawing power without being fully plugged in or properly inserted. As a side note, the CEM, quote, increased maximum add-in card total power to 675 watts, but that includes slot power. This is confusing for them to state in this way because the 12-volt 2x6 connector is rated to deliver 600 watts of additional power, just like the 12-volt high power cable, which has caused some confusion. Here's what the spec says, quote, the 12-volt 2x6 power connector delivers up to 55 amps of continuous current to provide a maximum of 600 watts of additional power to the add-in card on a 12-volt rail. So in other words, please stop saying 675 watts, unless you're also going to start talking about the slot. Extensive sections to the CEM were added to describe cable assembly best practices, warn that individual pins could see more than 9.2 amps, warn about low-level contact resistance and side loading, and discuss environmental durability. At least 25 millimeters of untwisted or bent wire past the plug is now required, and designs intended to get a smaller bend radius, like right-angle cables, are, quote, outside the scope of this specification. The ATX 3.1 revision 2.1 spec, released shortly afterwards, noted that, quote, the cable plug side of the connector has not changed and is compatible with new PCB header connector definition. To this day, the newest male 12-volt 2x6 connector spec is basically the same as the original 12-volt high power one. Even the newest revision isn't perfect. For example, as Aris pointed out to us, the spec says that for modular power supplies, quote, an additional 12-volt 2x6 PCB header connector will be required in the housing of the power supply. But it also says, quote, the PCB header is mounted on the add-in card and optionally within a modular power supply, furthering the contradictions of the spec documents. With that in mind, let's revisit CableMod's planned changes to V1.1 for the angled adapters. First, CEM 5.1. So CableMod said, quote, V1.1 adapters will include a CEM 5.1 female connector, but that wasn't the side of the adapter that was melting, and it was unlikely that that was going to help here. Secondly, connector tightness. The connectors did need to be tighter, but connectors melting in place when they were fully seated hinted at a different problem specifically for CableMod. Finally, connector wiggle. CableMod used plastic stakes to fasten down the male connector to the PCB, but the company outright said that, quote, it didn't affect performance in our tests and was done for, quote, the sake of user experience, end quote. The product page for the 1.1 adapter also listed, quote, improved terminals. The 1.1 adapter wasn't a fix, but that was the clear implication if you read the product page and from how CableMod delivered the replacement program. It didn't help, though. On February 8th of 2024, CableMod threw in the towel with a voluntary recall for all angled adapters through the US CPSC government agency. According to the CPSC notice, which is a government agency in the US for consumer safety, there were 272 reported failures out of approximately 25,300 affected units. a failure rate slightly over 1% in 1 year, and an order of magnitude higher than it had been in August. The phrasing used by the CPSC was that CableMod had, quote, determined that the male connector in the angled adapter could become loose during cable management and system use, overheat, and melt into the graphic processing unit, posing fire and burn risks, end quote. As far as we understand, we don't believe that CableMod ever conclusively declared a root cause, a cause of failure for its specific adapters, any kind of common cause between them. But in the absence of a clear answer, CableMod at least deserves credit for the replacement and the recall programs, because that much is good. Unfortunately, most companies don't go as far as issuing a recall for something like this. Anything short of what is legally mandated, normally they'll stop there. So we'll give them a lot of credit for at least doing the right thing with that. We also want to give CableMod credit for actively replacing or reimbursing cards for users who had failures with a CableMod product, especially one of these adapters, because that, it seems like the expected thing to do. You buy a product, it kills another product. Probably the one that caused the failure should pay for the loss of the other component, but that's not common. Normally you have to fight pretty hard for it, so we were happy to see that they handled it that way as well. It should be expected, but it is rare. They get credit for that. Now, the failure analysis lab we hired could not come to a firm conclusion as to the specific common cause of failure of the CableMod adapters. It did, however, have some key indicators for potential causes of failure for the ones that we sent in. So, as we stated in the beginning of this video, the key indicators of a failure for CableMod's adapters specifically included soldering work, choice of solder material, potential fractures in the pins as a result of the design, and general workmanship issues. That is a simple version of the timeline of events. So Patrick wrote basically this entire script. He spent a couple months on it. I think our total time in this as a team is over 300 hours now, mostly of research. So as we reach the conclusion here, a quick note that these kinds of deep dives truly require community support. We have over 300 hours invested into this piece, with most of that being research and validation. To support our efforts, please visit store.gamersnexus.net and consider grabbing one of our PC building anti-static mod mats with wiring diagrams, our soldering and project silicone mats, which are excellent for not only high heat tasks like soldering, but also for model building, painting, and crafting tasks, or our other items like our 3D drink coaster packs that include common PC component theming to provide you with high quality coasters that represent this enthusiast hobby in a unique way. You can also throw us a few bucks per month on patreon.com/gamersnexus. And thanks for your patience with these promotions as we continue to ramp our in-depth, hour-long coverage the past few months for true deep dives and investigations. Your support makes our investigations possible. Back to the conclusion. There's a lot more in the timeline. We stripped a lot out of it. Definitely an interesting story to follow. It's not over though. So after all this, ultimately, just like in the beginning, we don't really like 12-volt high power, but it is here to stay. And what we would recommend at this point, now that it's matured a lot, so just a big disclaimer here, it has been a good amount of time with a lot of revisions to all these specifications. We ran through a lot of them in this video. And so the recommendations we are giving now are based on now, just like the ones we gave a year or two, whatever ago it was, were based on then. So if in a couple years this spec continues to change, you can ignore this section because the recommendation may have changed. So based on today or times relatively near today, our recommendation, if this is causing you anxiety and you're worried about it, is to use a native 12-volt high power or 12-volt 2x6 cable at this point. If for no other reason, then it eliminates additional points of failure. Simpler is better. Fewer connections is always better. We said that in the first videos as well. Now that's our opinion, but opinions may differ on this. For instance, speaking with Aris of Cybenetics, he thinks 2x8 pins on the power supply is the best. Here's what he sent to us when we were talking about this. Quote, the best way to reduce problems is to use 2 8-pins on the power supply's modular board instead of a native 12-volt 2x6, since the former allows for more cable flexibility and are more tolerant to abuse in general. I advise power supply manufacturers to do this, but in some power supplies, due to a lack of space in the PCB, this can be an issue, so they are forced to use 12-volt 2x6 sockets, end quote. Now, we agree with Der Bauer that NVIDIA using 2 12-volt 2x6 connections on high wattage cards could restore and would restore some of the redundancy that was previously afforded by PCIe 6 and PCIe 8-pin connectors, having so many of them on the card with all that additional safety margin. So that would help there. We wouldn't want or expect them to actually push, say, two 12-volt 2x6 connectors worth of power into the card, because then, at least for those of us in the US, you are going to start exceeding the current limitations of the average breaker in a house for a circuit with just the GPU. It'd be pretty damn close, like 1200 watts or something if they pulled all of it, and then you got the rest of the system too, and whatever else is plugged in on that circuit. So we wouldn't want them to use all of that power, but having two of them would still allow for the redundancy while still getting some of the benefit, but not all of it, of shortening the PCB that they got from PCIe 8-pin. As for adapters, adapters fall outside the ATX and the PCIe CEM specs. If you're using an ATX 3.0 power supply with 12-volt high power or 12-volt 2x6, but it doesn't have that plug on the power supply side specifically, then it is using an adapter by this definition. There's no simple way to connect the sense pins with an adapter. For example, Corsair runs 12-volt high power connections out of two 8-pin connections on the power supplies we have on the PSU side, with one sense pin grounded to each, which means that if only one 8-pin is plugged in, the GPU will be signaled that either 300 watts or 450 watts is available arbitrarily, depending on which one is plugged in. Some adapter cables don't connect the sense pins to the PSU at all, like CableMod Stealth Sense. On paper, the most, we'll call it correct, adapters are the dongles that ship with NVIDIA GPUs, which intelligently ground the sense pins based on how many connections are detected. Obviously, that didn't prevent them from melting to start with, but it is important to remember that those failures, when they happened, were much different from cable mods. We'd also recommend continuing to always avoid sharp angles or pulling tightly on cables in general, but 12-volt high power and 12-volt 2x6 cables in particular. This has been known since basically before day one, actually. If at all possible, follow bend radius guidelines from the power supply or the cable maker. If you're using a male-to-male double-ended 12-volt 2x6 cable with your power supply, strictly speaking, the cable should have at least two visible sideband connections that run all the way from the power supply to the card. Since the card_cable_press signal is now supported on the GPU side, up to 3 wires may be used. If a native 12-volt high power supply meets spec, it handles sideband signals internally. Power supplies don't always set those signals properly though. As Aris from Cybenetics told us, quote, "Nobody follows Intel's recommendations, and you can see 600 watts shown as available with 12-volt 2x6 on a 650-watt power supply. This is ridiculous, and I'm so tired of writing this down on our Cybernetics reports." End quote. These recommendations aren't in the ATX spec itself, but they are in the Intel published Desktop Platforms Power Supply Test Plan. Aris continued with this, quote, "Many ATX 3.x power supplies ignore this Intel guideline and have a 600 watt setting in their 12-volt 2x6 connectors. Remember, this setting should not be applied on the cable, but within the power supply," end quote. Now, there's another aspect to this that we're not getting into today, but some third-party double-ended cables, like CableMod Stealth Sense, ignore the power supply and, quote, "signals to the GPU that a full 600 watts is available to be used. This isn't ideal, but it's intended to avoid another common issue, which manifests with a black screen and GPU fans running at max speed. Many of you reported having this problem in our survey that we ran. This is likely due to sense pins losing connection, whether that's from, to quote CableMod, fragile sense pins that can easily be dislodged, okay, or just vibration from thermal expansion. It was one of the causes. Since 12-volt 2x6 intentionally makes the sideband connections more tenuous, we expect this to become more common. If you experience this problem, it can be worked around by using a different cable. And then one last recommendation we have here too is the same as previously, a couple of years ago. Make sure the cable's fully seated. That still matters. It matters a lot, actually. It might be one of the things that matters the most after choosing a cable that is not designed with some kind of fault in it, like the CableMod adapters were, because there is not a ton of headroom, as we've talked about, and then pulling to one side can start to loosen one side of those contacts, like we showed in the original piece. So that still matters. make sure it's fully seated. And finally, the RTX 5090 gets a mention here at the very end. The card isn't out yet, and at the time we're publishing this, there are conflicting rumors about the device. In the past, leakers have gotten the power specs wildly wrong about GPUs, so we're not able to make any firm recommendations or commentary until the true specs are known. Currently, the leaks indicate a 600-watt TDP on the RTX 5090 from NVIDIA. However, last time leakers suggested an 800-watt or 600-watt GPU in consumer, it turned out that these were simply the recommended design guides for cooling solutions, not the actual power consumption. For sake of discussion though, if we momentarily just assume it is 600 watts for the true TDP of this card, then our concern would be regarding running a single 12-volt 2x6 connector for the card. The cable itself is not rated for 675 watts, as we said earlier, and this is a common misconception that it is. Between the cable, its limited overhead, and the PCIe slot, we would feel uncomfortable with how close these limits would be to the power consumption. Der Bauer felt the same way when we discussed it with him, and if NVIDIA goes with 2 connectors, they'd have plenty of headroom. For now though, until the specs are actually finalized, there's not much point in discussing this further, because it could just be the case that these TDP rumors are completely wrong, and we'll comment on it more once we know more. So that's our huge research piece on 12-volt high power, such that it exists today. It's been a pretty long road, been a huge amount of developments over the last couple of years specifically. So back in day one, the conversation was much different. It was very focused on that 30 series, later the 4090 cards, the NVIDIA adapters, and then over time kind of morphed to include these things like CableMod's issues and whatever else is going on, all the CEM changes, the mechanical guidelines, the ATX spec changes. So a lot of that has finalized at this point, or gotten to a more final state, which is why we wanted to cover it again, recap it all, get everyone back up to speed on how did it all shake loose now that we're about 2 years later, because it's been a complete mess, as the title says and the beginning said. So that about covers it though for this kind of mini timeline documentary thing on a new cable standard. Not something we normally do. I don't know, maybe we'll get another one. I guess we kind of did this with the 12-volt only spec when that was starting to be a thing. So anyway, that's it for this one. Thanks for watching. Subscribe for more. Patrick did a massive amount of research and writing for this piece. So just a thanks to Patrick as well on the team. And if you enjoyed this content, check out more of what we have, because recently we've run a couple cool pieces, like with Wendell talking about some of the Intel CPU failures. You can learn about that on the channel. Otherwise, subscribe for more. We'll see you all next time.